Hey guys, welcome to my newest workshop. You've chosen the topic working with Redis, and that's actually a great topic because Redis is a wonderful database which in certain aspects can improve your application performance. First of all, I would like to apologize because the lighting in this room is not very bright, but I'm not currently at home, so sorry about that. Okay, so what are we going to cover? We're going to cover what is Redis and why do we need it? What's so great about Redis? We're going to see how to get started with Redis, how to install it locally, how to run it, what it can do. We are going to see common Redis commands. We're going to see how we can design a database because it's very different if we compare it to a normal SQL database, for example, SQL Server or MySQL or Postgre. It's a little bit different um, because you don't have tables, you just have data structures which perform very well and you can use them to manipulate, store, save, retrieve data. Also, Redis is an in-memory database, which is an interesting approach because sometimes you want your data to be durable. If there's something wrong with your servers, for example, and for example your Redis instance crashes or the virtual machine on which the Redis instance is running suddenly stops working, you may want to retrieve the data in the database somehow. So we're going to talk about the persistence and the storage options and when do we need it and what we're going to pay for that storage. Then we're going to cover Redis configuration. What is Redis configuration? Most of the time we as developers or as software engineers, we don't need to configure Redis that much. It's already configured to be uh, working kind of to be working well in the most common scenarios. So if we need to tweak it, then it, it means that we have an advanced scenario or something like that. We have uh, something way out of proportion. And finally, we're going to see how we can use Redis from code. We're going to see smaller demos. I'm going to show you small samples of code which use Redis. And then I'm going to use it in a bigger project. I'm going to install it and I'm going to cover how to introduce Redis to a project you are already developing, for example. Good. So first things first, what is Redis? Uh, because it's a buzzword, a lot of people are talking about Redis, a lot of people use it. Most of the developers know that Redis is actually super fast. It's very performant, but what exactly is Redis? Well, Redis is a key value database. What that means is that you don't have any tables, you don't have any schema involved, you don't have any relationships involved. Redis allow you to insert data by a certain key. Consider the dictionary data structure in a typical C# application. The dictionary allows you to store a value for a certain key. For example, you can easily store a name to age pair. For example, you can say easily in a dictionary, John is 10 years old. Then Anna is 12 years old. Then Dimitri is 15 years old. You can do the same thing with Redis. So each value you store in Redis, each value should be mapped to a certain key. And the key is a normal string. So even for this simple scenario, for example, the name hpair, you can store that on a Redis database. I know that this doesn't sound very promising because typically you want to say, okay, but usually I have a lot of objects. Of these objects has a lot of properties. Of these properties have different types, not only primitive types, but something else. So how come Redis is so cool? How come Redis uh, is so usable in a typical production app? Bear with me. The bare bones of the Redis database is that you have keys and you store values, but it's not only a key and a value. Redis provides you very fast operations on some widely used data structures. We're going to cover them in a minute. So basically you can store a data, which is the value, inside a key. The key is a string or a byte array, but typically you use a string. And later the data can be retrieved if you know the key. And the value may be a very complex data structure, for example, a list or a sorted set or an object. So you don't necessarily use a primitive value. You can use a complex data structure, and Redis has first-class support for various data structures we're going to see in a minute. The best thing about Redis is that it provides atomic operations in an asynchronous environment. So if multiple clients try to increment the value in a Redis store, it will be done atomically, which means that every single increment in a value will be persisted correctly. There won't be any race conditions or something like that. So how to get started with Redis? Because I believe when you see, because my first impression with Redis back in the day, when I heard that there's a cool kid in the town, a Redis database, and when I mm, read online that it's just a key value storage, and I was like, okay, but how it can be helpful? Because I already have a key value storage in terms of a dictionary. So bear with me, it will get more interesting. So how to get started with Redis? There are three different ways to start using Redis. The first one is build it locally from the source code. This can be done only if you're running on Linux. So if we go to Redis download, we will see that there is a version 6, for example, version 5, and so on. But if you hit download, you will just download the source code. And you will need to run the following commands. You will need to run make, and then you will need to run Redis server in order to run Redis locally. But this can be done on Linux only, so it's not very useful if you are developing on a Windows machine like I'm doing. So the second option is to run Redis in Docker. To run Redis in Docker, you just need to go and say docker pull Redis. That will pull the image, and you need to read a bit on the Redis documentation. I'm going to show it in a minute. Docker Redis image, this one. We can see that to run an instance of Redis, we just need to say something along the lines docker run some Redis, name it some Redis, and this is Redis. And you can run it with a persistent storage. You have various options, but I'm going to cover them in a minute. So the second way to run Redis is by using Docker. And the third one is to use a ready-to-be-used cloud. For example, Azure, AWS, Google Cloud Platform, Redis Labs. All of these should have a free tier of Redis instances, but I'm going to use the following. Redis Labs, you can create an instance very easily. You can choose a free plan. The free plan doesn't give you a lot, it gives you only 30 megabytes of data, but it's more than enough to work with Redis, to play with it, to develop your application with it. It's good enough. When you create a Redis database, you will receive an endpoint, you will receive some password, and pretty much that's it. Of course, the free storage option on any given cloud doesn't give you advanced options like replications or bigger storages or some events, but it doesn't matter in terms of development purposes and testing how Redis works. It's more than enough. Good. So in this particular demo, I'm going to use a cloud, Redis Labs. So, how to work with Redis? How to start writing commands in Redis? Well, there are three options here. The first one is to use Node.js. You need to run npm install globally Redis CLI. Redis CLI, specify your host, specify your password, and specify the port. All of these are already given to us because we have the port right here, we have the host, and we have the password right here. So if we want to use Node.js, that would be more than enough. I'm going to show you the Docker way. All of these Redis command line interfaces have some commands which I'm going to show you in a minute. So bear with me, we just need to connect somehow to the Redis instance first, and then I'm going to show you different and various options and various commands. So if we want to use a Docker image, what we need to do is we need to create a Docker network with the following command. Then we need to run a server running Redis, and we just need to say, hey, I want a Redis instance which should be called my Redis. I want it to be in the following network, and I want to run the Redis instance, Redis image. Then this will run a Redis instance, a server, a database server ready to be used by different clients. Then I'm going to run a client, a CLI client, command line interface client, and the command is very easy to docker run it interactive, run it in the same network so that we can connect to the server, and we want to call the host, which is my Redis, and because we name it my Redis, this will connect. So let's go and create that. I'm going to first run the network, then I'm going to create the Redis server, and finally, I'm going to run the CLI. All of these commands are from the documentation, so it's nothing nothing special, it's nothing difficult. So currently I have connected to the Redis instance. So from now on I can write different commands. For example, set, hset, sorted set, add, get. A lot of commands are available here. The simple one, and we can see that we have an IntelliSense here specifying different options for the command. So if I want to say set name value, it returns OK, then I can get name and I will receive value. Not very promising for now, I know, because that's very simple, but bear with me. Let's see the common Redis commands. First, we can use primitive values. That's essentially the string data type. We have set and get, which allows us to set a value and get a value. For example, if I go and say set my special key to be 15, I will store the number 15 in my special key. Then if I say get my special key, you know what will happen. It will return 15. Don't mind the don't mind that it looks like a string right here, because even though it shows quotes, it still can be used as an integer, so it doesn't matter. Good. Then we have some other commands, for example, del, which means delete key. We have exists, which means check whether a key exists. And I can say exists name. And it will say 1, which means true. Exists age, false. Exists my special key, yeah, true, because I already specified here. Then we have an increase command, incr, and we can specify a key here. This will atomically increment a key. Atomically increment the key. This means that if I say increase my special key, it will increase it by 1. Or we can specify increase by, and I can give 10, for example. It will increase it by 10. This is super cool because it's working correctly atomically in an asynchronous environment, which means that if 100 clients are trying to increment a value at the same time, it will be incremented exactly 100 times. There will be no race condition. So that value here is, that operation is super important, and it's super easy to be used, because with a typical database, for example SQL Server, you need to store a timestamp, you need to store a concurrency token. It's more difficult than just increase the value by 1. You can also easily cache some values. You can say expire a value and then specify seconds, which means that if I say expire my special key 10 seconds, this means that in 10 seconds my special key will not exist anymore in the database. So I can use it as a cache. Set a value and set its expiration for 5 minutes, for example. And the database will automatically delete it. It's very convenient for cache storages. This is the expire command. The ttl command means just checks how much time is left for this key. And if I say get my special key, I will see new, because my special key no longer exists in the database. If I write exists, we can see that it doesn't exist anymore. So my special key was lived for 10 seconds, and that's it. So we can easily specify different expiration options. We can also say expire name for 100 seconds, for example. Then I can say give me the time left for the name, and it will say 95 seconds, 92 seconds, and so on. But if I decide to persist the key, I can specify good, try to persist the key, and if I specify ttl name again, I will see -1, which means that this key is indefinite. Good, this is pretty much all you need to know for the primitive values. It's super easy, but it doesn't matter. You will see that using Redis and working with Redis is actually super straightforward. It's very easy. Maybe you will need to read 2 or 3 days some documentation and you will get used to it. But the most important part about Redis is what are its use cases, and I'm going to cover them after we see the common comments. I'm going to cover all the use cases which are useful for Redis. So if you happen to have an application and you run into an issue or a problem or a business process which may be solved by Redis, just use it. So if you recognize some of these patterns I'm going to show you, just use Redis. Install it and you will be thankful later. So there are complex data structures in Redis too, not only the primitive types. So working with complex data structure doesn't require creating a key, doesn't require creating a key and then creating a list, for example. Redis will automatically create the key for you if it doesn't exist. And if it exists, the key should store a data structure which is supported by the command. So for example, if you decide to create a list for the key cats and then use a command which is for a sorted set, Redis will return an error. So let's start with the most commonly used complex data structures. The first one is a list. It's a normal list which contains series of values. So how to use a list? You can specify right push and left push. Right push and left push just add a value to the list at the different ends. So right push will add a value at the end of the list and left push will add a value at the beginning of the list. But it's just a normal sequential data type. So when you say right push, it will be added here, and when you say left push, it will be added here. Then you can do different operations on the list. The most important one is lrange, which needs to get two values and it will return a subset of the list, starting from this index to this index. And if you specify -1, it will return the whole list. So start from 0 and return everything after the 0. You have a typical stack operations, popping a value from the left and popping a value from the right, which means remove a value from the beginning and return it, and the other command rpop is remove a value from the end and return it. We also have length. So let's try a list, lpush, then we can specify a key, and then we can say insert my cat. Then lpush some other cat, lpush some other cat, right push some right cat. So if we say length of the cats list is 4, that's nothing, it's nothing strange. Then we can say lrange, give me all the cats in the database, and it will give us all the cats in the way we pushed them. As we can see, we said insert my cat at the beginning, then insert Sharo at the beginning, then insert lady at the beginning. So the order is lady, Sharo, my cat, and then we said insert right cat at the end. So if we say give me all of the cats, it will return all of the cats. But we can say arrange cats 1 to 2. It will give us only the first till the second index. So it's super fast to make. It's super fast to make subsets of a list. Super fast. Good. Let's continue with the next data structure. That's the set. The set contains unique elements without having any order, because the list had an order. The list had first, second, third, and so on. But the set doesn't have any order. The set just contains unique elements. Adding values to the set is with sadd, which means set_add. Srem means remove a value from the set. Member, check if a value is in the set. Members will return all values in the set. There are more commands, for example, union, which will combine two sets for us. So again, I don't need to create any key. I just need to say add to a set. The set should be my cars, and add BMW. Then add Mercedes. Then add Audi. Then we can say member my cars, and we can say Volkswagen, for example. No, it's not a member. Is BMW a member? Yes, it is. We can say members my cars, and it will return all the cars, but in no particular order, because the set is not a sorted data structure. It will return the values, all the values, but in no particular order. So if order is important, the set is not our data structure. Good. Let me see what's happening here. We don't have any questions, so let's continue with the sorted set. We have two more data structures to cover, sorted set and hashes, which basically give us everything which we can do with Redis in a typical web application. So what we have a sorted set. A sorted set has the same comments as the set, plus some additional ones, and it starts with Z. The interesting thing with the sorted set is that, again, it contains unique elements, but each element has a decimal score. And the set is sorted according to the score. So if we say Z_add expensive cars, 100,000 BMW, this will mean that it will add the BMW to the cars sorted set with a score of 100,000. Then we have Z_add expensive cars, 80,000, which is Audi, and Z_add expensive cars, 120,000, Mercedes. The sorted set will automatically sort all the values here by the score number. And then we can easily say Z_range expensive cars, give me the first two from the 0th index to the first index, give me all the values in a sorted manner. So if I go and say Z_add new cars, to be a little bit shorter, I'm going to say the score is 1000 BMW. Then I'm going to say 500 Audi, and then I'm going to say 1500, and I'm going to say Mercedes. So here I can say Z_range new cars, and I can say 0 to -1, which will return everything, every single car, and we can see that they're sorted by their score, from the smallest to the biggest ones. So we have Audi, BMW, Mercedes. Of course, we can add scores which are the same, so scores which are equal. The sorted set will still be sorted. We can specify, give me only the first two elements, and it will give us the sorted elements. So we have give me the 0th element and the first element. We can say give me the 0th element until the second element, and it will give us all the elements here. Here they are. You can see that the sorted set always stores the data in a sorted manner according to the score. Good, and the last data structure I'm going to show you is the hash. The hash is useful to store various objects. How we can store objects? Well, we can say something like this. hset some key, for example, user and its ID, name eval. hset the same user, this is just a key, h5. This means that this key now has two properties, name and age. And later we can say hget the key, give me the name. This will return only eval. But we can say hget o, the key, it will return both name and age. We can easily increment a property by specifying hinc by the key h1. So we can easily store objects here. We can say something like hset my car, and then we can say make BMW. Then we can say hset my car model, for example 6 series. hset my car year 2015. So we can store properties for a certain key. It's like an object which has key value pairs. Then we can say hget my car, give me the year of my car, 2015. Great. Give me all the properties of the car, and it will give me all the properties. Make BMW model, year, and so on. So we can use the hset to store more complex data structures, more complex objects, objects which have more than a single property. And to store different objects, for example, to store a user, we can say hset user and then specify the user ID. I'm going to show you in a minute how to design a database using Redis. So let me just cover again all the commands, because these are the most common commands you are going to use in a Redis data store. So first, the primitive values. We can set a value for a key and get it. We can set existing, we can delete it, we can expire it, and so on. Then we have a list. A list is an ordered values. Basically, it has an order, and you can push a value at the beginning of the list, and you can push a value at the end of the list. You can get a subset of the list very fast, and you can remove a value from the beginning and from the end. It's basically like a linked list, and it's working super fast. Then we have a set. The set contains unique elements without any specific order, and it's useful when you want to check whether a value is inside a set. We have a sorted set. where we have unique elements with sorted scores. So the difference between the set and the sorted set is that the sorted set has an additional value which sorts the data. And finally, we have a hash. A hash is essentially a data structure which is useful for objects. And you can store multiple properties for each set, for each hash. So now we understand what are the basic and the most commonly used data structures on a Redis database, but how we're going to use them and what are the common use cases for each of these data structures. Bear with me. I'm going to hit the 5-minute break, and then we're going to see how to design a database using these data structures. Five minutes, guys. Sorry guys, I said 5 minutes, but had small work to do. Okay, so let's return to designing a database. How to design a database? So, since Redis doesn't contain any tables, you don't need to design a schema at all. But you need to design what kind of keys you're going to use. Because if you want to store different objects in the Redis database, you may need to store different kinds of keys. For example, take a look at this. You can have one key which will hold the next user ID available. So if you have 5 users stored in the database, you will see here 6. If you have 10 users in the database, you will see 11. So you have a simple primitive value holding the user ID, the next user ID. And since we know that this value can be incremented atomically, we are sure that no two users will have the same ID. Then the next thing is to store the user as a hash. So we have a command which specifies multiple set. It's the same as hash set, but it's multiple set, and it allows us to save multiple properties. So the second structure we're going to use is the hash, and we're going to say, okay, so let's save the user with ID 1000, store his username, and store his password. And then we may say something along the lines, well, we need to know which username maps to which ID. So we're going to use yet a third structure to store each username mapped to each ID. So to store the users, we don't have a single table. We have a user ID primitive which stores the next user ID available. Then we have a hash storing each user. So we have an object for each user, a hash for each user, and we store the ID of the user here in the key, and we store all the properties there. And then finally, we create a hash containing all users mapped to their IDs. If we take a look at this Twitter clone in the Redis documentation, you will see that they designed the whole Twitter clone by just using a Redis as a database. So here it is. First, the user ID, user, the properties, and so on. We have a set, H set for the users mapped from username to an ID. Then we have followers if following. So how do we do that? We create a followers sorted set for each user. So for example, if we want to store the followers of the user with ID 1000, we're going to create a followers semicolon 1000, which will be a sorted set of all the followers, and the same with the following. So apparently for each user we create one hash storing the user object itself, and then we create two sorted sets containing the followers and the following of the particular user. And when we create a new follower, we can specify add a new follower to this user with this ID, and we can use the score of the sorted set to be the current time. This way we will have all the followers sorted by the time they added us. It's very convenient to use these data structures for various operations. Again, the user may have a list of posts. For example, in a Twitter, each user can post an update. So we can do the same. We can say posts 1000 is a key containing a list of all post IDs for a specific user. So posts 1000 means that all post IDs will be stored here as a list. And we can easily retrieve parts of this list by using range. We can easily page it because we can get the first 10 elements, then the next 10 elements, then the last 10 elements, and so on. Good, but this list is basically the user timeline. So we can push the IDs of his own posts. And we can create a separate structure to store the post itself, like this. And you can read the rest of the article. It uses PHP as an example, but that doesn't matter. The database design is important. So basically, we no longer design different tables and schemes and so on. We just design data structures which store our data, and we spread our data in different data structures. As we can see, we don't need to have a single object for the users. We have three objects: the user ID, the user with its data, and all the users mapped username to ID. Then we have two sorted sets for the followers and the following. Then we have posts, which is a list, and so on. So we create our database by creating different objects. This is how designing a database in Redis looks like. It's strange at first, I know, especially if you're used to SQL databases. It's very different, but bear with me because this is also super fast and super convenient. So let's see all the use cases of Redis, and this is by far the most important part of this lecture because you can learn about Redis from a documentation, from an online tutorial, and so on. You will see the different parts of Redis. For example, how to use a sorted set. That's not very important in terms of knowledge because you can read that. But the most important part is the use cases of the Redis and how we can implement Redis in your typical ASP.NET Core application. This is the most valuable thing in the current lecture. So let's see for what we can use Redis. First, we want to use the primitives. How we can use the primitives? First, we can use them as a session. We can store user-specific data, for example, shopping cart. We can store for each user, we can store, for example, a session ID in a cookie and send the cookie to the client. Then when we receive the cookie, we can store different parts and different types of values in our Redis instance by this session ID. We can store user-specific data, shopping cart, that's a perfect example. Then we can store an HTML cache. For example, we can store a HTML fragment of our page and directly return it. This is like a super fast cache when we want to optimize our application. So we can cache different HTML parts and we can improve the rendering. We can use usage and method billing. we can store how much usage each user has. For example, if we bill for different usages on our system. For example, you can run tasks, CI machine. We can run different tasks, and we bill our clients for each task which was run. And we bill our clients for every 60 seconds of running a task. So we can use Redis to store for each user a key user 1000. We can store something like 153 seconds worth of tasks. So when we decide to build a user, we can easily see, okay, this guy has 153 seconds. That's apparently $2, for example. So we can store method billing. How we can use lists? We can use lists for different feeds. RSS feed, for example, news feed from different sources. We can use social network feeds, timelines. For example, in Facebook or on Instagram, we have timelines there. And storing timelines as lists, it's very convenient because we can push the new object, the latest object, at the end of the list, and we can easily retrieve it later. So it's very convenient to use timelines. Also leaderboards, forums and voting platforms. For example, if you have various answers like Stack Overflow, where the best answer is voted by the community. We can store this in a list. So when we open a topic, in the list we will contain every single answer which needs to be rendered on the browser. So we can easily use lists in forums and voting platforms. Sets. Sets are used for analyzing. Many online stores analyze customer behavior. So each customer behavior may be put on a set. For example, this user has clicked add to cart. This user has clicked the following item. This user has purchased the following item. And later we can extract from the set the data and we can say, hey, give me all the users which purchased the following item. Give me all the users which added the following item in a cart but didn't purchase it, and so on. Because we don't care the actual order of the data. We don't care whether the user first added something to the cart, then purchased something. We don't care about the order. We care whether the user did something. We can track IP addresses. Sets can store everyone who visited a website. And because IP addresses needs to be unique, we can store something like unique online visitors. It's very easy by using Redis sets. We can filter content. For example, sets can store inappropriate words. So when a user writes something in a text field or a text area, we can easily validate it against the set, whether the set contains some of these words. What about sorted set? Sorted set, question and answer platform like in Reddit, Stack Overflow 2. We can use sorted set to rank the best voted answers. So if the answers are voted, we can sort the answers based on the voting. So the score of the answers will be their votes. So the sorted sets will sort the data by the votes. We can use it for gaming scoreboards, for example, high score lists. Every time we have a high score, we can use Redis. We can, especially if we have lots of users, which need to be sorted in a high score, and we need to get the latest 1000, the top 1000 players. This is the data structure we're going to use in a Redis instance. We can also schedule tasks. We can use sorted sets to make priority of a task. So these are common use cases which can be found online on various web applications. So remember the following: every time we have something which has a date and needs to be sorted by the date, a list is a good data structure, because the newest items are pushed either at the end of the list or on the front of the list. So if you constantly push the newest item at the front of the list will contain everything from the newest to the oldest item. We need to use sets for various types of data, which will be doesn't matter in terms of order, like the content filtering, the IP address tracking. It's super fast to check whether something exists in a set. That's the most important part here. And we can use sorted sets to rank different types of answers, for example, to have some high score lists, to give priorities. So every time we have something which needs to be prioritized, we can use a sorted set, whether it's a task, whether it's a better player than the other one, whether it's best voted answer, and so on. We can use hashes to store various objects. For example, user profiles, we can store the user profiles there. We can store user posts, user data, comments, articles, different user generated data in general. So it doesn't matter what kind of business process we have. We can store different user generated data. We can also store multi-tenant metrics. We can store data for each tenant. If you're not familiar with what is a multi-tenant application, it means that we have a single application and each user has a separate database. And the application recognizes that this user needs to call this database here. That's the important part. So when we have multi-tenant metrics, we can store in a Redis instance data for each tenant. Other use cases, general use cases, we can use Redis as a message queue because it has a native publish subscribe pattern, which is super easy to use. I will show it in a minute. We can use it for real-time data which changes super fast and we want to be stored in memory. For example, stock pricings. Because stock pricing is changed super fast, it's a good idea to store it in memory. We can use it for machine learning purposes because when we deal with large volumes of data, and that's typically the case with machine learning, these large volumes of data needs to be processed fast, and when we use Redis it will be super fast. So Redis is good for machine learning. Now let's talk a little bit about persistence because that's important. If we have our data in memory, it's very unsafe to store everything there. It's very difficult to recover from disasters and it's not durable. So how do we use storage and persistence with Redis? Basically, Redis has two types of persistence and both can be turned on at the same time. By default, only the first one is turned on. And depending on the use case, you may enable persistence options or you may disable it. It doesn't matter. It depends on why are you using Redis at the first place. So in some cases, you may not need the data at all. For example, memory cache. You just want to cache the data, but otherwise you get it from a SQL Server, for example. So if you want to use Redis as a cache, you already have the persistence in the SQL Server. You just use Redis for its performance purposes. So in this case, you may disable the persistence at all because you don't care about whether the data will be lost. It's in the SQL Server instance, so it doesn't matter. In some cases, you may not need the data that much. This means that if you lose, for example, 1 second of the data, it's not a problem. Because if you have a lot of data entries, and if you lose only 1 second, that may not be a problem for your business case. For example, when you have a lot of analytics going on, and if it doesn't matter whether your website was visited, for example, by 20 users or 22 users, it doesn't matter. But if it matters whether the site was visited by 2000 users, but it doesn't matter whether it was 2002, 2010, that's just a detail, then you can use persistence which is not that durable and it may lose 1 second of data. Also, if you log data, if you constantly log something, if you lose 1 second of the log, it may not be that important for you. It depends on the business case. And finally, in some cases, you may need 100% persistence of the data in the Redis instance. For example, message queues, or if you use Redis as a data store, as a single data store. You're not combining it with SQL Server or PostgreSQL or whatever. You're just using it as a single storage option. Then you need 100% of the data most of the time. So it depends on the use case, and depending on that, you have different options to configure your Redis instance. So the two types of persistence are RDB and AOF. RDB is a point-in-time recovery. It's super fast to execute and it creates a backup. Basically, it means that when you say save the data from Redis, it will save it for you for the particular moment. It means that if I create an RDB backup 5 minutes ago, I will have 5 minutes of lost data if a disaster happens. And the RDB allows a faster restart with big datasets. So if we have an RDB backup and the Redis instance crashes, or for example, the electricity crashes, and the Redis instance needs to be restarted, it will populate the data from the RDB. But it's a point-in-time recovery. The other option is AOF, which append-only file, which means append-only file, which basically means the following. It logs every single write operation. Every single write operation. So this one is more durable because the data cannot be corrupted, because it just adds and appends data. With this one, for example, while the Redis is creating the backup, if the machine crashes and the backup is not complete, the backup will be corrupt and it will be irrecoverable. So the AOF is a little bit more durable. And the AOF option has 3 settings. The first setting is don't synchronize, which means leave the operational system to synchronize the file with the hard drive. That means that on most Linux machines it will be 30 seconds. You can say I want to synchronize on the hard drive every second. This means that if you turn AOF for every second, you will lose at most 1 second of data. And you will need to decide whether that's good enough for your business case. Most of the time it's good enough. 1 second of data loss, it's not that much. But it depends on the business case. And of course you can say async. Async, it means every single write operation will be written to the hard drive. And that's the most safe option, that's the most durable option, but it's very slow. It's very slow relatively, of course, because Redis is actually a super fast uh, database. And when we turn on the persistence of to be async, we are slowing it down a lot. It's better if we're after performance to put 1 second sync, because 1 second sync is super fast. It's almost as fast as no sync at all. So 1 second sync is the default behavior, and it's the best of both worlds, because it will synchronize super often. We can lose only 1 second of data, which may be a lot, depends on the business case, but it's fast enough so that we can use it. In a typical production scenario, we should add the 1 second synchronize, and we should add a point-in-time recovery depending on the business case. For example, once a day, once every 1000 entries, once every 100 entries. It depends what we store in the Redis persistence. If we use the Redis database as a single only database, we should turn on async, because then every single operation is important. How to configure that? Well, Redis configuration is actually a file which you can configure. Here is the default configuration of the Redis, and if you want, it's very long and it's self-documented, so if you want to understand better what's going on here, you can go and see and read it and so on. But most of the time you don't need to change almost anything. So how to configure persistence? Well, the default value for append fsync, which is the AOF persistence, is every second. So basically, this is the default option and it's good enough. But if you want to change it, you just need to find the value, go to the configuration, and you can say append fsync always or append fsync no. But the guys at Redis tell us, if unsure, use every sec, the default value. Then the RDB persistence can be written in the following manner. Save 101. What this means is that you can say, I want to save 100. I want to save every minute and every 900 values. So if we have 900 values, they will be saved. And you can put multiple options here, so we can have multiple and various configurations when the RDB to be created. So let's see that too. If we specify here, save Here it is. So save after 900 seconds, if one entry was saved or changed, make an RDB. So every 15 minutes we will have an RDB persistence if one entry was changed. You can say every 300 seconds, change that. At least 10 keys changed. This is important. It's important to understand your business process. How valuable are these entries and how often you want to save them. So there is no magic value here, but if the data is super important for you, it's a good idea to say save every 15 seconds if at least one key was changed. So this configuration here is good enough. Save every 15 minutes. Again, it depends on the business scenario. So let's now see how to use Redis from code. First, I've prepared some demo code to see how to use Redis from the C#, and then we're going to open a bigger solution to see how to add Redis to that solution. And again, like I promised the last time, I'm going to give you exercises. So if you want to improve your Redis skills, or if you want to test how exactly Redis works, if you want to try designing a database with Redis, I'm giving you a code, I'm giving you a task, and if you need assistance, you can call me, you can write to me, or if you want me to make a code review of your workshop, I can do that. So I'm going to hit another 5-minute break and we're going to look at the code. Okay, so let's see how we can use Redis from a C# code. First, we need a Redis server installed somewhere. We can install it locally if we have a Linux machine. We can run it in a Docker, but the easiest way is just to use the Redis labs quote. Here it is. I've created a free tier database. To connect to it, we need to get the host, the port, and the password. All of these are available here. The host, the port, and the password. Good. Then what we can do is we can have basic operations. All of the operations we saw as commands are available here, are available through a C# interface. So the first thing first, we need to use a connection multiplexer. We can use an interface, but that's the interface which allow us to connect to the Redis database. We can instantiate it by using connection multiplexer.connect and provide the connection string I specified earlier. So how to use a basic database? We need to say var database equals redis.getDatabase. From here on, we can use string set, string increment. This is the primitive data type. All of the methods have asynchronous and asynchronous options. So if I write string, I will see everything about the string. String get, string list, range, get set, increment, length set, a lot of things which we can do on a primitive value. All of these methods represent a command from a Redis point of view. So basically we say set a value here. We want to set a value with this key and number 10. Then we want to increment it asynchronously. Then we can get it. Nothing very special here. We can use a sorted set or a set or a hash, whatever we need. So for example, if we need a hash database hash, we can say, okay, hash set. I want to set a value in a hash. And why I can use the example from the presentation. I can say, okay, let's create var entries equals new hash entry, which has username, and we can store that in the hash like this. Of course, we can call the async method here, and we can await it. So every single data structure has an interface, and we can easily set or get values. So the sorted set key is sorted set add, and I'm specifying add John, add George, add Anna, add Maria. Then we can say sorted set range by rank. Give me a subset of the sorted set starting from 0 to the second element, sorted, of course, sorted by their rank. We can use task when null to optimize calling the database. So when we need to call the database multiple times, it's a better alternative to write await task when null, because all of these will be sent concurrently and it will be more optimized. The other option is to write await before each one of these, but then we're blocking before every single entry. So it's not that optimized. The best option is to use await task when all. Good, that's a basic database. Then how we can use publish subscribe with Redis? A publish subscribe is done very simple with Redis. What we need to do is we need to say get subscriber from the connection multiplexer, get subscriber, and then we can say subscribe on this channel. This is the channel. And then we can say if I receive a message on the channel, do something with the message. And you can use Redis as a message queue like this. Then we can say queue.publish, and we say publish on this channel the following message, and it will be sent for us. So it's very easy to use Redis as a message queue. It's super easy to add Redis as a message queue with mass transit. So if you want to use it, you can use it as a message queue. Let me just find where we can use mass transit Redis. Yeah, you can use mass transit with Redis easily because it's a super simple message queue like this. Of course, if you want to use an advanced message broker, you should use something else, for example, Kafka or RabbitMQ or something like that. But for a simple operation, this message queue may be sufficient. There are two types of executing messages. The first one is executing messages in order. You need to get the subscription and then specify what to do with messages. This means that each message will wait for the previous one to finish. So it's a little bit more blocking, but you have an order. And concurrent execution of messages is by the following syntax. Queue subscribe, directly we provide channel message here and execute it. This way we don't have messages which wait for each other. Good, publish and subscribe, it's actually super easy. Fire and forget. Fire and forget, sometimes we may want to call the Redis server, but we don't need a response from it. Then we can specify a command flag, fire and forget. This can be specified on every single operation. So every time you want to just send something without expecting a result, you can call fire and forget. Where does this comes useful? Well, it comes useful, for example, if we have a database, we have a key, and we can say set a string here, but then we want to make it expiring. So we don't care whether this operation returns a result. We just want to fire it to the Redis server. So we can easily specify fire and forget here, because we don't care about the result. And finally, the no values. The no values are important because by default Redis returns 0 and 1. It doesn't return a no. In the same way C# uses no. So to check for a value whether it exists or whether it's a no, we need to check value is no. Because when we get a string, we receive a Redis value object. so we can check it whether it's a no. If we cast the value as an integer, we need to check it against 0. And if we cast it against knowable integer, we can use the no. So that's important to understand. If we don't cast the value to any type, we can check it by the isNo property. If we want to cast it as an integer, we can validate it against 0, and we can validate that against a knowable int with a no. Good. This is a basic demo of what Redis can do. Now let's see how to integrate it in a typical microservices application. This application was used in one of my previous workshops, Eventual Consistency Done Right. So if you're not familiar with the app here, just watch the workshop and you get used to it. So I've given here various tasks you can do with Redis on the actual server. So this is a system which allows dealers to add car ads for renting, for example. The system has authenticated users. It has an administration, notification service, watchdog service, which checks every other service for its health, and it has a statistics service. The statistics service just remembers how many cars are in the systems and how many times the cars were viewed by the system. So apparently what happens when somebody adds a car, currently no Redis is installed in this project. When somebody adds a car, here it is, we do some validations, we create a car, and then we send a message to another microservice, the statistics, saying that a car was added. So the following message is processed by mass transit consumer here, which just gets the message, checks whether it's duplicated, and says something along the lines: give me the statistics from the SQL server, add one because a car was added, and then save it. That's not relevant here. So the problem with this approach is that this value is not atomic, which means that if two cars are added super fast in our application, we will have a race condition because both cars will be added, two consumers will be fired. The two consumers at the same time will ask, hey, how many cars do we have currently? And both will receive 5. Both will add 1, and when we hit save changes, both will save the value 6, which means that the statistics will not be correct, because what we want to do is we want for each car to have the value incremented. So the operation currently is not atomic. So this is a good place to introduce Redis. We may store the statistics of the app to a Redis instance. So this is the first task we can do. A second task is we can implement the most viewed car ad statistics. For example, top 10 most viewed car ads. How to do that? Well, we can use a sorted set. We can use a sorted set, and for each car, we're going to store a score of its values. We can cache some of the queries, for example, get categories or the default search without any parameters. We can change the message broker with the Redis one. That's nice to have. It's not necessary. RabbitMQ is good enough. We can change a whole database with the Redis storage. For example, the whole dealer's microservice may be replaced with a Redis store. So you can try everything you want from here. I'm going to implement some of these, and I'm going to introduce Redis to the system so that it will be easy to use. Okay, so first things first, we need to add Redis as a service. So in our startup class, we want to be able to add memory database, for example, something along the lines with the configuration, with the current configuration. So I'm going to add the following in the commons project. There is a common project here, infrastructure service collection extensions. I'm going to add a method which says public static iService collection add memory database, this iService collection services, and I'm going to say I want to have iConfiguration configuration. Good. So every time I want to use Redis, I'm going to add it in the startup like this, add memory database. For now, I'm going to use it only in the statistics microservice, so I'm going to add it just here. The next thing is I need to install the Redis C# client. The Redis C# client, one of the best ones because there are multiple clients available, is Stack Exchange Redis. It's written by the guys who wrote Stack Overflow, so we should trust it. They use that library in their website. So we're going to install Redis. There are numerous packages with some modules, with different modules which add additional functionality to Redis. For example, extensions Newtonsoft is a library which allows to use JSON and so on. Here it is. For example, that's an additional module which can be used with Redis. So it adds, for example, serializer, some other features, add and retrieve complex objects because currently we cannot do that, and so on. Here it is. We need to read a bit to learn about it, but nevertheless, it doesn't matter. I'm not going to use that. You can check it out later if you want. I'm going to link that in the description too. Here. Because it has nice to have features. Okay, so I've installed the Redis client, so I should be able to say using Stack Exchange Redis like this. Good. Then what I need to do is I need to add the connection multiplexer as a singleton. It's very important to have the connection multiplexer created once and reuse it throughout your application. That's super important if you want to have maximum performance. So I'm going to say services.add singleton iConnection multiplexer, and then I'm going to say connection multiplexer dot connect. And here I will need to get the Redis configuration. So what I'm going to do is I'm going to create a new file. I'm going to say memory database settings. To be the same as here. Public string secret. I'm going to say public string connection string, something like that. Good. Then I'm going to need to extract that the same way I'm extracting it for my authentication. I just need to extract it like this. Var connection string equals configuration get section memory database settings. Give me value called connection string. Good, that will be my connection string. I will need to add it to the application settings file. So if I go to app settings, I will need to add it here. But since I'm using a Docker to run the app, so if I want to run the app, I'm going to use the Docker compose file, and I'm going to say Docker compose build first, and then Docker compose app. I'm not going to run it right now. I will need to add the connection string to here. So what I need to add to the statistics environment variables is I need to specify memory database settings underscore underscore then connection string equals to the connection string I used here. Of course, if I don't want to use any if I don't want to use any quote Redis, I can create a Redis container here, but I'm not going to do that right now because we don't care about the containerization of the app, and it's not a lecture about Docker Compose and Docker, so I'm going to skip that. But in a typical scenario, we want to add a Redis container here. If we use something like Kubernetes, for example, or some other orchestration. But for the sake of the exercise, this will be more than enough. If you decide to try some of these tasks by yourself, you can do it by replacing the connection string here. Or you can use this one. It's free after all, so you can use mine. Good, so we added the services. And what I want to do is I want to add iMemory database service, which will connect to the actual Redis instance. Memory database. Good. Let's register this. We just need to say services at transient. I want to have iMemory database mapped to a memory database like this. Good. So we're going to add functionality to the memory database in on demand. When we need to add some values, for example, get values and so on, we are going to add methods to the memory database. So iConnection multiplexer, Redis, we need to initialize that from a constructor. And the important part here again is to have the connection multiplexer registered as a singleton. So I registered it as a singleton. Good. Now we have Redis added to our application. From now on, we can add different values here. Good. So let's implement and change the statistics. Currently, the statistics are added to a SQL Server database. We don't want to do that. We don't want to store the statistics to SQL Server anymore. We want to change it to use Redis. So what we can do is we can say, okay, let's use private iMemory memory database, which is essentially the good. So we no longer need to execute this. What we want to do is we want to say this memory database increment. And that's it, increment. I'm going to add private const string, which we will need to extract in a minute. Private const string statistics total cars key equals statistics total car ads. Like this. And we can add something like task increment, and we can add string key here. Await this memory database increment, and we are going to provide statistics total car at that key, like this. Now what we need to do is we need to implement the actual method. So what we can do is var database equals this Redis let's create it connection to sound more abstract. Get database, good. Then what we can do is we can say return database dot increment string increment async and provide the key like this. Done. This will return the actual value. So we can, it's the actual value after the change, but we don't need it, if I have to be honest, in our statistics, but we can make the method more usable. So right now the statistics will be updated by using the memory database. Okay, that's good, but then we need to update the full statistics in the statistics service, because when somebody gets the statistics from the web client, he needs to receive the values from the actual database, from the Redis database. So what we need to do here, the statistics doesn't need to be a data service anymore, because we don't need a DB context. What is the statistic output model? It has total car ads and total rented cars. I'm going to inject iMemory database. I don't need mappers and such. Cool. So how to create a statistics output model? Well, first we need to get the values. The values should come So in the statistics service, we can say something like return new statistics output model, and the total cards should come from this memory database get as integer, and we need a key. The key is the same like this one, but we need to extract it. So I'm going to add a class statistics constants. Which public class memory database keys, and I'm going to move the constant we used there. Like this. Then in the caret created consumer, I'm going to remove that. I'm going to say using static statistic constants dot memory database keys, like this, and it will be included. Then in the statistics service, I need to provide the same thing, and I'm going to say statistics total car ads data key. Then for the rented car ads, even though we don't have that functionality implemented, we can add the same constant. We can say statistics rented car ads date key rented. Let's be shorter. Done. for the rented car ads, we can specify get as int statistics rented car ads. And we're ready with the statistics. From now on, the statistics will use the Redis database, which is better in terms of performance, especially for atomically incremented values. Good. What we can do next is we can implement most viewed car ad statistics. So apparently what this means is when somebody opens the details page, we need to send a message saying car ad viewed message. We need to get it on the statistics microservice and store the view on Redis. So let's create a message first. We need to add a message, viewers, car ad viewed message. Car ad viewed message. So this message needs to have the car ad ID, manufacturer, model, and I guess an image so that it can be easily stored. Well, it may have more data. It's not that important, but let's add car ad ID. And manufacturer, for example, and model, so that we can list of the most viewed URL, so that we can list most viewed car ads. Let me think for a minute. Well, we can just send the car ad ID, manufacturer, and model, and the client may call the dealers to get additional information about that, but it doesn't matter actually. Both options are fine because we need, for the statistics, we need this information too. So car ad viewed message. So when somebody opens a car on the details page, we're going to say var car ad equals this, return car ad. Then we are going to say that we want a message car ID, manufacturer, manufacturer, model, and image URL, like this. And then we're going to say await this save the message. Good enough. And then from the other microservice, we need to create a consumer. So I'm going to add car ad viewed consumer. I'm going to say iConsumer from car add viewed message like this. Again, I'm going to need the Redis instance, private read-only iMemory database. Memory database, and here I will need to increment the current carat ID. So I'm going to need a sorted set which has a key named something like car views car ID, something like that. Car add views car add ID, and I'm going to store the car add ID with a score of the views like this. So first we need the key. I'm going to add in the statistics constants, I'm going to say public const string statistics car add views key like this. Then in the consumer, I'm going to say I need the in-memory database. Task increment sorted set. Sorted set key and value. So in the consumer, I just need to specify something along the lines await this memory database dot increment sorted set and use the statistics key using static statistics constants memory database keys. Use the statistics car add views key. This is the sorted set key. Then we need to add the value, and I'm going to say context dot message dot carat ID like this. So let's implement that. I need to implement the get too. So var database equals this connection get database. Then what we need to do is we need to say database dot get string get and we need to specify a key. Fortunately, we cannot return that because this is wonder how to extract it as a generic parameter. If I box it and then cast it. This should be more than enough. Good. So what I did here is first I casted the result as an object and then to a dev value. Good. Increment sorted set. Again, var database equals this connection get database. The get database object should be short-lived. This is why I'm getting a database object for each method here. It should be short-lived and it's convenient to use. It doesn't need to be a singleton like the connection multiplexer. Good, 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 good. So increment sorted set. What I want to say is database return database dot sorted set increment. This is what I need. I need to say this is the key and this is the value I want you to increment. Sorted set, I think. What is missing? Redis value member. So basically I said increment the sorted set by the following key with this value incremented by 1. So in the carat viewed consumer, I can easily say increment the sorted set context message carat ID. So every time somebody views the message, views the carat, a message will be sent and the views will be updated here. Looking at that, we don't need all this information here, so I'm going to delete it. We don't need it like this. But what we can do is we can, when a carat is created, we can send additional information, manufacturer, model, price per day. And when a carat is created, in the consumer, we may store the date of that carat. Here we may store an object of the carat. So we may store in Redis the carat. But I'm going to leave that for now. Good, so now we have the views of the objects. Each carat's views, we store it in our Redis instance. How to retrieve the data, I'm going to leave that for you. So when we say we need to add something like that, HTTP GET public async task from something top car ads, the most viewed. So what we need to do here is we need to call the car ad views service. We need to inject private read-only iMemory database, memory database, something along the lines. So here we can say await this memory database, and we can say get sorted set, because we can make a range on the sorted set. So let's go here and add task of the value. So in the carat view service, we can say something like var car adds equal await this memory database top car add IDs actually await this memory database range sorted set. We can provide the key using static statistics constants memory database keys, and then we can say statistics carat views keys. I believe that's the sorted set. Then we can say give me the last 10, like this, the top 10, because sorted sets go from the smallest to the largest item. They are sorted from the smallest to the largest. So by providing negative numbers, we are essentially saying start from the end. Give me the last 10 numbers, the last 10 entries. So this will return the biggest 10 entries. From here, we need to get all the data. So we need to get the data for each top car ID. The idea here is every time a car ad is created, we have a message for that, price per day, and maybe public string image URL get set. So a car ad is created. I'm going to add the image URL, car add image URL, like this. And on the car ad created consumer, here we can say await this memory database create hash because we want to store each car add data as a separate hash. If you don't remember what a hash is, a hash allows us to store different objects. So we can store all the car add objects here. Let me create a method for that. I'm going to say var car add values equals dictionary string object. We can use reflection to improve this code and create a dictionary of properties which contain the key and name, but that doesn't matter. There's a root value dictionary in ASP.NET Core which can be used. It creates exactly this, a dictionary from string to object, and does it very fast. It's super optimized. The problem is that in the context message I also have some other things. Actually, I only have the carat ID, so it's not a bad idea to use it. We can call it like that, root value dictionary. The problem is that its name is a little bit route oriented. It's a request response naming. Okay, let's remove it. But this dictionary is very optimized. So if you want to understand how to create a fast object to dictionary, check the source code in the ASP.NET Core repository. We may even implement our own dictionary using the same techniques they're using, or we can use the root value dictionary directly in our code, but it's named strange. A root value has nothing to do with carat created consumer in general. Good carat values. Carat values. So we need to say this memory database set hash. We want to have a key. Here we need to store for a hash an object for each different carat. This is why I'm combining the key with the carat ID. Then I need to provide carat values like this. So this will store every created car in the Redis with its data. So the next thing we need to do is to implement the following. Let's go to the memory database, implement that. We need to implement the range sorted set, which is just get database, return database sorted set range by rank. Or range by score. No, we need by rank here. So by score means that we need to search for a specific score, but we don't care what is the score exactly. Start end. Okay, there's dev value, which needs to return an array of dev value. Good, we extracted everything from the sorted set. Give me the list, box it, cast it to the value and return it. Okay. And this is by far an integer because we store the carat ID. Okay. So if we store the carat ID here, increment sorted set, that should be also by dev value. So this should be like this. No, we cannot do it. with a generic. We need to use an int and a string overload if we want to have a string version. So if we want to have a string version, we need to add another overload. Okay, good enough. Let me fix it. Car add view service, get most viewed car ads. And now what we need to do is we need to extract all the objects from the memory database by their IDs because we already store them. Let me build the app to see whether it's okay. Good. It was built successfully. So yeah, right now what we need to do next is we need to extract for each carat ID, get from the Redis database the object we stored. This object we stored here, we need to extract it from the Redis database and use it here. This is the idea. For each ID we need to get that. Good, good. I believe that's it for today. Hope you like Redis. It's quite different as a database, but I promise you it's super fast. It's very performance oriented. I suggest you try adding some features yourself. So if you want to practice, here are the tasks. We implemented that. We partially implemented that. We only need to map the hashes to the result, and you can use Redis to cache some of the queries, categories and default search. You may check the Redis extensions because it will be easier with them. Where are the queries? Carrots controller. Here it is. You can cache that. You can cache that because these values doesn't change that often. So we can cache this in a Redis instance so that we don't need to call the SQL Server. Also, what we can do is we may cache the search. We may cache the search if the query is empty. So if all of these are null or empty, all of these are default values, we may cache the results from the database. So only if the user tries to search for something, then we're going to add the actual SQL Server. Otherwise, we're going to extract the values from the Redis. This is also an interesting task which can be used with Redis. We need to add an expiration. We need to validate the query. We need to call SQL Server only if Redis is empty, and if the query is not the empty default query, we need to use the actual SQL Server. The other tasks, We may change the message broker with a Redis one. That's not necessary because RabbitMQ is working great. And we can, so Redis has a publish subscribe pattern, which is good enough for simple scenarios. So if you want to use some publish subscribe without a lot of advanced options, you can choose Redis. And finally, if you're more adventurous, what we can do is change the whole database for the dealer's microservice with a Redis storage. This will be a lot more interesting. So guys, hope you liked the workshop, hope you liked the lecture. I'm going to push this the project and the source code to the GitHub repository, and I'm going to add it on Patreon. Okay, if you don't have any questions, we may finish the workshop. Thank you guys for listening and have a nice evening.